Is now a good time to start?
Yeah, feel free to kick it off, Patrick.
Great, thank you. Hi everyone, my name is Patrick O'Neill. I'm moderating this meetup today called Building Your First Graph Solution. It's brought to you today by WeCloud Data and TigerGraph. These are some of the events coming up. Today, August 12th, Introduction to Graph and Use Cases, Building Your First Graph Solution. September 2nd, Introduction to Graph and Application Specialized Session Supply Chains. September 30th, Introduction to Graph and Application, Fraud Detection and Anti-Money Laundering. October 14th, Graph's Influence on the Power Grid Users in New York Hands-On Workshop. So the agenda for today is, first we will start with an introduction to knowledge graphs, then introduction to Graph and TigerGraph. Then we will have a comparison to relational databases and when to use graphs with real-world use cases. And then finally, we'll have a walkthrough of creating your first graph through Graph Studio. This is a basic graph. I'm not sure how many of you have seen something like this before. So you have the nodes, which are more commonly called vertex or vertices. You see these vertices here, user. This is a Twitter graph representation. And then you have the edges, which are the relationships between the vertices. So the vertices and the edges can also have properties. So for the follows edge relationship, it could be like how long they've been following since, and then for the vertices, it could be like their location and any kind of information like that. So I'm sure you've all noticed when you search on Google for a famous person, a panel of information shows up on the right hand of the screen. This panel usually includes some basic information such as birth date, spouse, and children, important works or achievements, and a list of other notable figures that have some connection to this person. This information is made possible through knowledge graphs. Knowledge graphs are a collection of interlinked descriptions of entities and objects. While the standalone objects are important themselves, it is from understanding the relationships between these objects that provide the most useful insights, which make the knowledge graph so powerful. Google launched its version of a knowledge graph in May 2012, which allows Google to improve the relevance and accuracy of its search results. It goes beyond simply matching keywords to queries and instead delivers results that better understand real-world entities and their relationships to one another. Facebook also uses a knowledge graph to improve its search function by connecting relationships among its users through information it collects about objects such as the music, movie, celebrity, and places that interest its users. Due to the rapidly growing scale, the storage and maintenance of most real-world knowledge graph is becoming challenging. A recent version of the Google Knowledge Graph had over 570 million entities and over 18 billion relationships. To deal with the large-scale knowledge graphs, the AI community has been using machine learning not only to quickly build and structure knowledge graphs, but also to infer links between data points that would not be noticed otherwise. However, machine learning is also getting benefits from knowledge graphs to more deeply understand data such as text, video, and audio that cannot be fitted well into the relational database. There's a massive untapped potential in combining knowledge graphs and machine learning. For example, a huge amount of knowledge which is represented on the internet is available essentially for free and is not being used by current AI systems. A hybrid knowledge graph and machine learning system can hugely benefit from this knowledge to better understand the world, to organize and infer missing knowledge. That ends my intro. It's my pleasure to introduce Dan Barkus, developer and advocate at TigerGraph. He is currently focusing on building educational content. As a developer advocate, he's responsible for building out tools, demos, and learning to help developers more easily use TigerGraph in their use cases. Dan has a background in IoT, VR, and healthcare, having worked at Optum in their R&D department. Outside of work, Dan can be found 3D printing things, programming, microcontrollers, or racing drones. Over to you, Dan.
Thank you very much, Patrick. I'm going to go ahead and share my screen so we can all get started. I just do want to say that this will be an interactive demo. So anyone who would like to participate with the demo can do so. And I'll just quickly walk you through some of the steps to do that. So we're going to be using TigerGraph Cloud for our demo. And you can get to TigerGraph Cloud by just going to tgcloud.io. And I'll drop that into the chat for anyone who wants to do it. It's entirely free. You just have to give us your email address. You can go ahead and create an account. And then from there, you're able to spin up a free instance of TigerGraph. So we'll be doing that for this demo. So if you'd like to follow along, go ahead to TigerGraph, tgcloud.io, create an account, and then I'll walk through building out our first solution. I had some stuff in here a little bit about graph databases, but I'll just roughly skim over this because Patrick did a great job of explaining those in the beginning. But really, a graph database is a way of linking together disparate data sources to gain more insights from them. So what do I mean by that? You know, data kind of has its value where if we take a table in a database and you can gain insights from that, and you can gain insights from another table, and then you can combine those insights together and you can kind of get an idea of how those tables relate. But with graph, it's not about taking those disparate insights and trying to figure out how they work together. It's about taking all of your data as a whole and generating those insights based off of the entirety of your data rather than just disparate sections of it and then combining those at the end. So you really get much more value out of your data when you look at it as a whole and when you combine it with these different external data sources than just kind of siloing everything and looking at one section at a time. So as Patrick was saying, graphs are made up of nodes and edges, or vertices and edges, depending on how you want to talk about it. Both are correct. But basically, you can think of a node or a vertex essentially as an analog to a table in a relational database. So a node will have an ID, and it will also have attributes within it. So those attributes would correspond to each one of your columns. So you may have something like here, a payment. Payment may have some information with it about, actually, this next one is a bit better. Payment might have an ID, it might have the amount, and it might have some more information about it as well, maybe a payment type or a credit card number or something like that. And then also, as Patrick noted, these edges, while they do help combine these unique concepts, they can also contain data on their own. So edges can also contain attributes. So for example, here we have a order and a payment is being accepted, and we have the date that that payment was accepted on. So now instead of just having our order, just having our payment, you know, we now have how they relate to each other. Okay, this person paid for this order with this payment, and here's this additional information of when it happened. So that's, you know, this specific example, person ordered and payment is accepted, you know, that's something you can easily do in a traditional relational database. But then where we start really getting value from it is being able to attach those to each other. So instead of just being able to say, you know, this person paid for this order this way, we can now look at that payment and we could look at all of the different orders tied to that payment, and then potentially even the customers tied to that payment. And we can say, okay, this order, this payment method is being used across a bunch of different orders from different customers. You know, what's going on there? That seems suspicious. And already we have this insight in the graph because it's natively connected that way. We're able to see those connections and recognize when there are situations that may be outside of the normal or we may want to dive deeper into. So graph really just makes those easier to do. Some common use cases, supply chain management. fraud detection, and user journeys are really kind of the big top three that we're seeing out there. I mean, in addition to the traditional knowledge graphs, things like, you know, Google is a graph, Facebook is a graph of people being friends with each other, posting posts, social media graphs, things like that. I'll briefly walk through just one of these. I know we're going to get into some more depth on these later on in some of the later sessions, but I just want to kind of, I guess, prime you or get you excited for those. So supply chain management, supply chains are huge, complex beasts. You have manufacturers building components for things. So like you have people building chips, microcontrollers, things like that. You have people that then assemble those chips onto circuit boards. And then you have another stage in production where you take the circuit boards and you build them into parts, you know, you add your plastic components or whatever. And then those parts go into vehicles, and there's different model lines of vehicles that have different parts in them. So you have all of this to keep track of, and trying to get a holistic picture of that when each one of these is in its own separate database across different departments in a company, that's just ridiculous. You know, it takes months of being able to gather those insights to be able to then plan out how you need to manage your supply chain to make sure that you're able to produce enough parts for a specific model vehicle based on the forecast of how many you think you're going to sell. You know, it's this complex beast, and being able to just take all of that and put it in one place where you can look at each one of these aspects of the supply chain, of the manufacturing process, of the sales predicting process, all in one place, just allows you to gain so much better insights from it. So Jaguar Land Rover was one of our customers who used TigerGraph to kind of take this graph approach for their sales forecasting and for their supply chain management. And we were able to, you know, build out a graph for them that took in 12 different data sources with 23 total tables, and turned a process that normally took them 3 weeks into a 45-minute job. So it's not necessarily, you know, this is TigerGraph specifically, but it's just the power of graph, of being able to take everything and put it all in one spot in a way where it still makes sense and carries that kind of individual aspect to it while still being able to query it together. So today I'm going to walk you through building out a very simple social media-esque graph. So we're going to have people who are going to create and like posts. Those posts will have hashtags, and then people can also send and receive messages to each other. So this is sort of what we'll be creating. We'll be creating an actual graph within TigerGraph. So let's hop on over to Graph Studio and let's see what that process looks like. So you'll go to tgcloud.io, and that will bring you to this page. It may bring you to the dashboard, in which case just click on My Solutions and you'll get brought to a page. Yours will most likely be blank because you probably don't have any solutions yet. That's what we're here for. So you'll want to click Create Solution in the top right. And for this one, so TigerGraph, we have a bunch of starter kits available. So these are pre-populated, pre-built out graphs with all of your data in them, with sample queries, with your schema fully built and everything like that. So you could clone one of these and just get into it if you wanted to see what a pre-built graph looks like. But we'll be building ours out, the whole point of this. So we'll be starting with a blank graph. Going to next. So as a TigerGraph user, you do get one free tier instance. So that free tier instance, you get one free tier instance at a time, I'll say. So you can spin up this free tier instance, and at any point you could tear this down and spin up a new free tier instance. So we'll just go ahead and we'll keep these all default because these will just be our free tier instance. We'll click next. And then this is where we'll actually want to start changing things. So we'll want to give our solution a name. So this is TigerGraph 101. And we'll also want to set a password and a subdomain. The password by default is TigerGraph, all lowercase, all one word, and I'm going to keep mine that way. And then our subdomain is where this graph solution will actually live. So this is the URL that you will use to connect to your graph solution. So I would call this something like TG101. Do note, it has to be numbers and letters and hyphens, no underscores or any other special characters in here. So that can be a bit of a gotcha, but you'll just need to give that a unique name. And then click next, where you'll be brought to this overview page. And then you can go ahead and click submit to provision your graph instance. I already have one up, so I'm not going to go ahead and submit it, but this will take a minute or two to spin up on your end. So while that's doing that, we'll just kind of dive a little bit deeper into our schema, and then we can go back to the graph and work on it from there. So let's take this schema out of the context of kind of these blobs and lines between them. And let's look at what our data structure will look like a little bit. So these are our nodes. This is the representation kind of each of our what would be tables. So we have one for our people, and our people will have an email address, a username, their actual name, and a date time that they joined at. As well as we'll have posts, which have content, we've got to post about something, date time that it was posted at, and a flag as to whether or not that post has been deleted. Tags are hashtags, so they just have the contents of them as just their tag. What is that hashtag? And messages have a subject and a body. And then we also have some edges. We don't have a graph without edges, so we need those. So sent message, we're going from a person to a message, and this will contain some attributes as to who it's going to and what date time it was sent at. Posted is for posts, so from a person to a post. So this will contain the post time, which is the date time that was posted at. Received message, same as sent message, except we also contain some information here about when that message was opened. Liked, a person is liking a post, so that's an action that they're taking. And we have a time that they're doing that as well. And then hashtag, this is just a relationship between a post having a hashtag. There isn't really any additional information that we need to store there. So that's kind of the basic idea of what we'll be building out. So let's hop back into Graph Studio and start actually building it out. So when your solution comes up, you'll see that it's changed from a yellow circle that says processing or starting up to a green circle that says ready. Then once you have that, you can just click on your solution and these 4 boxes right here, applications, and then Graph Studio. And this will take us into Graph Studio. This is where our UI interface for TigerGraph, where you can do everything, more or less. So one thing I do want to say though, everything that you can do through Graph Studio is available to you through REST interfaces. So any action that I'm going to take through Graph Studio can be executed by code. Creating the graph, setting up the schema, everything like that. I even have, here's a quick example of using one of our Python connectors to do all of our graph actions. So although I'm going to be giving this demo, clicking through everything as kind of like my first graph, anything that's done here could be done programmatically as a service, or however you want to do that through code. So you could interface it with it from Python, JavaScript, anything that's capable of making REST calls. You can interact with TigerGraph, and we even have specific connectors out there for, I believe, Python, JavaScript, and Java, where you can just natively execute functionality on your TigerGraph instance directly from code. So the first thing we need here is we need a graph, or we need a schema first. So we'll click down to Design Schema, and that'll bring us to the Design Schema page. Up here is our toolbar, which is where the important things that we'll be working with are. So this little circle with a plus is to add a vertex type. So we'll go ahead and we'll add in our person vertex. Their primary ID is going to be a unique identifier for that person. I'm going to leave this one just as ID. And it's important to note that when you create a primary ID, the vertices primary ID is not available to you during query time. So if I wanted to query this vertex based off of what its primary ID was, I would not be able to, unless I click this as attribute checkbox. So this says, this is not only our primary ID, we're also going to duplicate this as an attribute within our vertex, so that way we can use it for querying. So if you want to be able to query your vertices, whatever your data is, off of this primary ID, you just need to check that checkbox, and then you'll be all set. So here we can go ahead and add our attributes. So we had email, which is a data type string. We have username, again, a string, and then we also have their actual name and their join date, which is a date time. So one thing to note here is that we have these sections for default values. By default, TigerGraph has default values that it will assign. So this is if there is no data. With TigerGraph, you do not need a full set of data. There are no nulls, I guess. So you can't have empty data. So by default, it's going to give it a default value. You can view those default values in our documentation. For strings, it's an empty string. For date time, it's an epoch time of 0, so it's 1970, and so forth. But if I were to try to add a person, and I had a username, a name, a join date, and I did not have an email, I would still be able to add that person, their email would just default to the default value. So it's just important to note that there. That may be different than some databases that you're used to. So we have our person. Next, let's add in a post. So post, again, very similar idea. We're going to have a unique ID. We'll set that as our attribute just so we can query on it if we need to. We'll have content, which is a string. And we will have posted date, date time. And lastly, we have deleted, which is a Boolean. So I'll just go ahead and go through and add in the rest of these vertices based off of our schema there. Hashtag, tag. And so this one, for hashtag, I'm setting the primary ID as our tag because we don't really have any other additional information we want to store with our hashtag. You know, our hashtag is going to be unique based on what it is. So therefore, we can use the word of our hashtag as our primary ID. So we'll set that to our tag. Go ahead and create that. And then lastly, we'll add our message. Which is a string. And then we also have a body statement, which is also a string. So another thing that's kind of cool that you can do here is with any of these. So this pencil icon will allow you to edit them, but you can kind of change up the style. So right now, a bunch of blobs doesn't really, just looking at this, tell us what we're doing. So one of the cool things that we can do is select an icon where we could do something like person now, and we hit OK. Now we've got a better idea of what we're looking at when we look at our schema. So now that we have our vertices, let's make this an actual graph and let's create some edges. So that can be done with this little arrow icon over here, add global edge type. So the first one we'll do is for our person creating a post. So I'm going to click on person and then I'm going to click on post. And that will allow me to just create an edge. So I'm going to call this one, posted. And now there's this directed checkbox to talk about. So there are two types of edges that you can have. There are undirected edges and there are directed edges. So in undirected edge, you can traverse bidirectionally during your query. So an undirected edge, you can go forwards or backwards. So I could go from post to person, from person to post. A directed edge only allows you to go one way, but it implies a relationship. So in this instance here, a person creates a post. That makes sense. A post cannot create a person. That does not make sense. So therefore, we would want this to be a directed edge because a person is creating the post. There's no opportunity for the post to create a person. But now, I know I just said that you can only traverse a directed edge in one way, and that might sound like a big limitation. And it would be, but that's where we have this reverse edge. So we have our posted edge, which is a person creates a post. And what we'll also do is we'll also create a reverse edge. So we're going to create another edge going from post back to person, saying reverse posted. So what this allows us to do is maintain the schema of our graph, the idea that a person is creating a post and that that's not a bidirectional relationship, while also still allowing us to traverse that edge in either direction, because now we can traverse our forward edge, our posted, or we could traverse backwards along our reverse posted edge. So I know it may sound a little confusing, like why would I make this directed edge and have this reverse edge when I could just create an undirected edge? But for the schema and for the way that your data is structured, you really should be making things in a way that is implicit of your data. So a person creates a post. You know, we don't have that reverse capability. And then just like with our vertices, we can also create attributes if we need to. So posted, we have a post time, and that is a date time. Another thing to note here is that we're not just limited to one edge between one vertex type. So if you'll remember, our people can also like posts. So we'll need to create an edge for liked. And the same idea here, this is a directional edge because the person is liking the post. And then for this, we also have a like time. and that's a date time. Now let's add our post to our hashtag. So our hashtags, or our posts rather, have a hashtag. So this is has tag. This is again directed because our posts have hashtag. Those hashtags don't have posts. And we had no attributes for this one because we don't really need any. We just need to establish that relationship that the post contains those hashtags. And then lastly, we'll just want to create edges for our messages. So we can have a sent message, which again will be directed because we're sending the message. We can't reverse send a message. It doesn't make sense. So sent message, and we're going to have a to user, which will be a string. And we're also going to have a send time, which would be a date time. And then for this last one, I'm going to do this purposefully incorrectly, just so I can show you that it's not that hard to change up any of these things. So this one is received message, once again directed, but oh no, I went from person to message instead of from message to person. So we can go ahead and we can just change that here in our with these drop downs where we select our vertices. And then as well, we'll just add our attributes here. So we have from user to be a string. And then we have sent time. And we have opened time. There we go. So another thing that I want to just make note of here, even though we're not doing this necessarily with our graph schema, but an edge can point from one type of vertex back to the same type of vertex. So for example, in this case, if we wanted to show is friends, if we had a friendship relationship between users, we could easily show that. So you can link from one vertex type to another vertex of the same type to establish a relationship like that. So we're not going to need this edge for our graph. So we'll just go ahead and delete it, and we can do that with the delete button. Last thing you'll want to do before you leave this page is make sure to press this publish schema button. This actually puts your schema in place on the graph rather than just on this interface. If I were to leave this page, I mean, obviously it would warn me, but if I were to leave this page and refresh it or something, none of this would go into effect. So you just got to click publish schema to make sure that that happens. So now what we've done is we've created a schema, but the thing is we still don't have a graph. This is just a schema. This is just a representation of the data that will be within our graph. Now, TigerGraph allows you to have what is called a global schema. So that's what this is. We are in our global view. So this is a global schema. And if I were to create now a graph, so we can create multiple graphs if we wanted, but if I were to create a graph now, I can choose which bits of that schema I want to include in my graph. So say I had some huge, we'll take, maybe the supply chain example from before, where we have this huge schema that interfaces with all these different parts of a business, but I want to make a graph that really only interfaces with the manufacturing side of things. I could go ahead and I could create a graph and I could only include the vertices and edges that are related to the manufacturing side of things of that broader graph schema. We'll just go ahead and we will create this graph. And this will take a couple seconds just for it to actually create the graph. And then we can dive into that and we can take a look at how to start linking up our data and some of the cool things that you can do with graph. So like I said, this will take about 30 seconds. While that's going, I will paste in a link. So I've created a fake, oh goodness, I hate the Zoom overlay. I've created a fake data set that you can use to load into your graph, and I'll just paste that into here. So it's just a couple CSV files in a GitHub repo, and you can clone this just by downloading it as a zip. And then from there, you can extract that, and you'll have your data here. So we'll use that in a minute. So if we go back to our graph, we'll now see that we've switched over to our graph. So we're in graph, my graph. We could hop back out to our global view if we wanted to. But you'll see that when we're in our graph, everything is more or less identical to our global view, except we have these little globes here on our vertices and edges. And that just signifies that these also exist within the global space. So I could, if I wanted, create vertices specific to this graph that would only exist in this graph, and those will not have that globe icon on them. Or I can pull in stuff from the global graph, and that's where we'll have that. So the next thing we'll want to take a look at is data mapping. So now that we have our schema, we need to actually attach data to it. So how do we do that? It looks like it's already got my files. That's nice. We'll go ahead and delete these. That's what I get for using the same graph for all my demos. But anyway, we can go ahead and we can click Add Data File, where we could then grab our files from earlier. Sorry, let me just clear these out of here. So we can click this plus button to upload our files, and then we can go to our TigerGraph 101 page. We can drag all of our files at once, select open, and those will be uploaded to our server. While this web interface will allow you to do things, upload them from a local machine, you can also attach to an S3 bucket, and you could pull your data from there. And additionally, we also have a Kafka loader that will allow you to real-time consume data from a Kafka stream and load that directly into your graph. So there are plenty of options of how you can get data in here. This is just the method I'm showing you today. So we'll start by loading in our users. So if we click on this, we'll see a representation of our CSV file. And the first thing we'll notice is that our header is in our data section. So we'll just want to check this checkbox here that says has header. And now we can see that our header has been added to our header properly, and we have all of our data, and that's what it looks like. So another thing that you'll want to note, so if we go over to posts, we can see that this looks like a mess. And that is because posts has large bodies of text, and those have commas in them. So that's breaking our CSV. Fortunately, when creating those files, I put in enclosing quotes around it. So by selecting our quotes as our enclosing character, we'll see that now it's adjusted our content so that it looks proper. So that's just something to take note of when you're adding these files. Just make sure that you're taking a look at what they actually look like when they're in here and adjust your delimiter, end of line, terminator, or enclosing character as needed. So by clicking add with one of these files, it'll just add it to our space. And now we can start doing our data mapping. And this part's pretty cool. So these two crossed arrows up here, map data file to vertex or edge, we select our data file, and then we select our vertex. So here we can see that we have all of the columns from our CSV file, and we have all of the attribute types from our vertex. And what we can do is we can start linking these up by clicking on one and then clicking on the other. And that creates a mapping between them, which is great. You know, you can go through and we could do this for everything else. But if you've done a little bit of planning beforehand and you've made your attribute names match that of your CSV, then we have this handy auto mapping button right here. And I can just select that and my data will automatically be mapped for me. So if you have a huge CSV file, it'd suck to go ahead and click through everything. So that auto mapping feature is very nice to help prevent you from having to do all that work. So that's our person, and we've attached that directly to a vertex. But let's take a look at something like our likes. So our likes aren't tangible in a way. You know, we don't have a specific attribute of or a specific node in our graph that represents a like. So we have to tie this to something else. And we can do that. We can take our likes and we'll tie them to our liked edge. So now we see our CSV file, which is our liked file. These are each of our columns. And we also have our edge. So we have our source vertex, our target vertex, and then any attributes. So the source vertex, because this is a directional edge, is the vertex that it's emanating from. And the target is self-explanatory. That is the destination vertex. So for this example, our by user, so this is the person who actually liked. So that's going to attach to our person. Liked post. So that's the post that they liked. So we're going to tie that to our post. And then we have a date time that they actually liked it at. So those all tie together nicely. So let's bring in some more of our data sources and start loading in maybe some more complex data. So once again, this is our messages. We'll just have to set our enclosing character so that way everything fits nicely. We can add that. So the way that TigerGraph loads in data. So all data is upserted. So any data that is already existing in the graph if you go to load in a vertex with the same primary ID, then the data that's currently in the graph will be replaced by that new data. So say I had a person here with an ID of 1, and I loaded in another piece of data that had an ID of 1 to that person, then it would replace the attributes. So say my person's name was Nick, and my new ID 1 person, their name is Fred. I load in that data in my graph, that person will have the name Fred. So in addition though, edges also have to point somewhere. Here, I'll use the hashtag as this example. This is actually a much better example. So we have our, we have our posts, and our posts contain our hashtags. We'll get back to messages in a minute. So here's the thing though. I can tie this post vertex to this hashtag edge, and I can say that post ID 1 has this hashtag. I do not need to point my posts CSV to the actual hashtag vertex, because in creating this edge, the edge has to have somewhere to point. So if I have not created this, a vertex for this hashtag compatible, if I have not created it, then by the process of me creating this edge, it will say post ID 1 points to hashtag compatible. Well, hashtag compatible doesn't exist, so it's just going to create that vertex. And this is where those default values come in. So say, for example, I had something, I had a message and I had that tied to a person, but I did not have a corresponding person in my users file for that person. The person who received the message would still be created because that edge needs that person to exist for that edge to be there. Just those attributes of the actual person, so their name, email, username, we don't have those because those aren't contained in the edge. So those would become their default values. So in the instance that a message was received by a person where we did not have that data for the person would still be created. They would just have an empty string for their email, an empty string for their username, empty string for their name, and that default epoch date for their join date. So let's go ahead and finish linking up this data. So we'll attach post to our post, and this looks like a great candidate for auto mapping. So we'll go ahead and select that, but we can see that our ID, so our unique ID of our post, ties to its unique ID, content to content, posted date, and deleted, so forth. So that's nice and easy there. Now, one thing you'll notice is that this data is not structured perfectly, and that's just the real world. Even though I made the data set, in the real world, not everything's going to be perfect. So here where we have our hashtags, these are kind of all broken into separate sections. So for each one of those, we just have to map that to our hashtag. So I can click organize, post, oops, bad one, post to post, and hashtag 2 now to hashtag. Now I'll just create another edge, or another mapping rather, that links hashtag 3. And then we'll just create one more mapping to link hashtag 4. And then additionally, we want to create our post, tie our post back to a person. So we'll just take our post is our ID by user. So the user that created the post, we'll tie them back to our person, and the posted date will attach to the posted date. Now here we have our messages. So we just didn't finish linking this one up before. Messages again, ID, subject body. Once again, great candidate for auto mapping. There we go. And then we will need to tie in our received and sent messages. So again, our ID is our message, our to user. So this is the person who received the message. And then from user, send time, open time. And we'll just do that last mapping for our sent messages. Message by user to user, send date. So there we go. So that will load in all of our data. So we can select this publish data mapping, and this will just essentially set in stone this data mapping. So there's one thing I do actually want to make note of here, because while it is what I said, it does work a little differently than expected. So where I said where we linked these hashtags, we just linked them by the edge. So we'll create that hashtag. So that vertex will exist. The only issue that comes from that, if you remember when we were designing our schema and we had to select as attribute for our primary ID, if we want to use it in a query, because this ID is essentially duplicated as an attribute, when this is created just by the edge, if you recall, we don't add attributes when we create them from the edge because we don't have those attributes going in. So while this will have a unique ID and it will load in our data correctly, where we will have a hashtag for each one of our hashtags, if we go to query on those hashtags, because they only have that unique ID from that edge, we will not be able to say, get me the, what was one of our hashtags? Get me the organized hashtag. So in order to do that, I'm just going to manually link these to each other, just so that way we're able to directly query based off of a hashtag. So once again, because this is imperfect data, we're going to have to tie this a couple times just for each one of our hashtag values in our original data source. So another cool thing to note here is, had I structured this data better, say maybe we only had one hashtag field and it had a bunch of hashtags that were then separated by a delimiter, what we can use are our token functions. So a token function allows us to essentially perform an action to a piece of our data while we're loading it. So we have a bunch of functions here that can do things like typical data conversions, convert to an integer, convert to a Boolean, check if a value is true or false. You can concatenate different lines together, change to upper or lowercase, all sorts of things that you can do while loading in your data just to lighten the data processing on your end. Let TigerGraph do it, no problem. And this gets added in like this. So this one, actually, hold on a second. No, it's not the best example. Let's add in a token function and we're going to concatenate two parameters. So for example, if I had maybe I was doing an IoT graph and I had a sensor that was taking a reading and I needed to create a unique identifier for that sensor reading, I could concatenate, the name of that sensor, the ID of that sensor, and the date time that it was read at. So I would then tie in, two of my attributes here, and those will concatenate those together, and then I could tag that, attach that output to our destination. So you're not just limited to kind of what your data is structured as, you can do a little bit of that data manipulation within TigerGraph itself directly within your loading job. This was, okay. So I'll go ahead and publish this data mapping. And then we can head over to our load data tab and we can actually start having some fun now. So we'll see that this looks exactly like our data mapping, which is good. If we click on these files, we'll see some information about them. We don't have any information currently because we haven't loaded them yet. So what we can do is we can load any file that we want by clicking on that file and then selecting this play button, or we can load all of our files at once by just not selecting anything and clicking our play button. And this will just give us a little overview of exactly what we're loading in. And we can just confirm that that is what we want. So this will start the loading process. We'll see these progress bars above each one of our data sources. And we'll also see over here a count of each type of vertex and edge. And in the bottom right, there's a chart that will show us that trend as well. So as these start loading in, we'll see the chart start filling out, and we'll see these numbers start increasing. So this will take just a few seconds to load. And it should pretty much be done by now. Chart might take a sec just to represent that, but all of our data is in the graph. Now we can start exploring our data. So this Explore Graph tab here is where some of the really cool stuff starts to happen. So the first, we have kind of this submenu now. And this first submenu allows us to sort of select vertices. So over here, we can pick vertices by type. So by default, everything is selected. So we'll just select a few random vertices of each type. And if we hover over each one of these, we can kind of see what it is. So our hashtag here is forecast. We can see that it has tag forecast. Here we can see our person, the attributes of that person. So we can click this hide icon to just hide anything. And I'm going to display just a couple people. Now, while seeing the data kind of as its own blobs is cool, it's not really what we're here for with the graph stuff. So I'll take one of these people and I'll double click on them. And this will expand out all of the edges and vertices that are attached to that person. So from this, I can see all of the messages that that person has sent or received, all of the posts that they've either liked or posted. And yeah, so we can get an idea of that. And then again, with any of these, you can again double click on it and sort of expand out from there. So here's other people who have liked that post, and here are the hashtags of that post. So that's kind of how to just expand out from one. And say we had a specific person who we wanted to find, say person, we'll call them person 51. We could enter that up here, person, our specific vertex ID, and there they are. There's person 51. Once again, we can double click on them, get all this information. But double clicking on them to get everything isn't always what you want. Sometimes you just want to explore out across a certain edge or look for a certain vertex type. So that's where expand from vertices comes in. So I'll just once again add in person 51. And what we can do here is expand through those vertices. So this right now is set up to work exactly how double clicking on them does, where it expands across all vertex types to any type of destination vertex. So that's what that did. I just clicked on that, and this will grab 20 of our edges. No problem. But that's, once again, not what we want. I want to find out what posts this person has posted. I just care about the posts that they've posted. So what I'll do here is I know that a post is a type, so I'll select that. And then what I could do is I could just say, there's only one edge type, right, that leads to posts. So we can just say travel through any edge you want, but just stop when we reach a post. And we'll click expand. So that did it. That expanded out to posts, but we'll see now that that didn't exactly do what we want. We still have all these liked edges. And that's because I didn't select just liked here. We have liked and we have posted that go to posts. So because of that, we didn't get what we want. But we could just unselect that and select posted. And now when I click expand, we will only get the posts that this user has posted. So that's the basics of these expansion steps. And if we want to go one step further, we can add expansion steps to there. So say I want to find now all posts and all hashtags. So I can select hashtag. Now this one, because we do only have one hashtag edge, I could select just the edge, or I can select everything. It doesn't really matter because there's only one edge there for us. So now when I click expand, we'll do our first expansion step where we go across all posted edges to get any posts that this person is attached to. And then from there, we're going to go across any of the edges from that post towards any hashtag vertices, and we're going to display those as well. So when we click expand, everything will unfurl here. And we'll see this is kind of messy. So you can at any time reorganize the graph by clicking change layout and then clicking again on force. There's a couple different layouts you can choose from. Force is typically the most legible, but there are plenty of other ones as well if you're interested in more of like a tree structure or other things as well. So feel free to kind of play around with those as you query the graph and see what is the best way to represent your data. But here we can see these connections between these posts, and we can even start to see some cool things here where these three posts each have the same hashtag. So we can get an idea of what this person typically posts about, because now we can see that these three posts are tied together by this collaboration hashtag. Seamless ties these ones together. So already we're starting to see some of our graph connections, and we're really only going 2 levels deep. So let's look at paths now. Obviously there's these graph connections between all these different posts and their hashtags and these different things in here. Let's take a look at how we can say traverse things a little bit more specifically. So say, for example, I wanted to find how user 50 and user or person 20, I want to find the shortest path between them. So most likely, this is going to be the case as we found, where it is a post that either one of our users has posted, and the other user has also liked that post. So this is the single shortest path between these two users. The shortest path is just through one other vertex, and that happens to be how they're connected. We can also get all shortest paths, which will find any of these short paths. So most likely, once again, through posts that they've either mutually liked or that one person has posted and the other person has liked. So there's that arrangement. And then additionally, we can do show all paths. Now this obviously has a little bit of a warning, because as soon as you start traversing more and more edges, that just broadens the possibilities of vertices you could end up on. So this path length here allows you to limit that so you don't break things. These are each a path length of 2. And as you can see, that's because they have 2 edges between each person and these intermediary nodes. So there is an edge here for liked, and there is another edge here also for liked. So that is a path of 2. With our graph schema, we don't have any paths that could be a path of 3. There's no, if we take a look back at this, there's no real way that we could only traverse 3 edges if we wanted to go, from a person to another person. From a person to a hashtag, once again, that's only 2 edges. We could go maybe from a message through a person, through a post to a hashtag, and maybe that's 3. But in the current way that we're trying to interface going from person to person, there's nothing that will have an edge length of 3. So if I were to click find paths here, we would get the same exact result. Now, increasing that to 4, now we have the ability to traverse, say a post that person A posted a post, person C liked that post, person C also posted this post, and then person B, who we're trying to attach to, liked that post. So our graph just exploded because we've opened this up, and you can see how increasing that number to 6 would give us an even crazier result. Yeah, so that is a bit much, honestly. So we can go ahead and clear that. Now let's take a look at finding connections. So this is similar to our path finding. So let's pull up 2 people, 51 and 57, let's try. And now let's go back over to find connections. So I'll select both of these, hold down Shift to select multiple. And now I can say find connection paths. This length is set to 4. I don't really want the graph to explode like that again. So I'm just going to drop this down to 2. And we can see here's a path between them. But one thing we could see if we didn't want it to, actually, let's see if this finds more than 1. Oh, oops, because we had both of those selected. There we go. Right, so this will just return our shortest one. But what we could do here is limit this. So if I only cared about traversing those liked edges, so I only care about posts that both users liked, rather than a post that one person posted and another person liked. I only care about posts that are mutually liked between these 2 people. Then I could set that with these parameters here by limiting the connection type, the edge types, or the vertex types that we're traversing through. And that limitation would be applied to this query. And then lastly, we have our queries. And I'll hop into those really quickly. And I'll show you some of the things that we can do with that. I don't intend to get too into actually the syntax and writing the queries in this. That's a whole other video, but I just want to give you an idea of a little bit of what is possible. So as much as I love live writing my code during demos, I'm going to copy in a query that I've already written. So here we have a query. We'll start with the simple one, and then I'll pull in a bit more complex one just to show you some of the cool things that Graph can do. So this one is simple. This one will just grab all the hashtags that a particular person has posted. So I'm going to hashtags from person, create query, hashtags from person. And then we're just going to paste in our query from before. And we'll also need to say that our syntax it looks like our names here were a little bit different caps. So what this, oh boy, there we go. There we go. So what we're going to do with this query is we're going to say, take an input person, so the ID of that input person, and then we're going to say traverse from that person to any of the posts that they posted, get those posts, and then from those posts, return all hashtags that this person has posted. So what this will do is just find all of the hashtags related to any posts that this particular person has made. So let's do person 60, say, run our query. And this will return a list. This is a graph overview, this is fine if you're looking at things through Graph Studio, but what you'll actually be getting if you were to interface with this through one of the REST endpoints is you would get this JSON as a result. So this would have, this tag is the vertex type tag. So we're returning a bunch of vertices of the type tag. And then each one of these entries within that tag array is just describing our tag. So this is our interactive tab. It has the attribute of tag, and that word is interactive, and it is a vertex of type hashtag. So you could then have your downstream application consume this JSON and do whatever you want with the result of your query. And like I said before, anything that you can do through this Graph Studio interface is a REST endpoint. So all of the stuff I was doing before, loading data, mapping data, designing the schema, it all has a REST endpoint that you can just do all of that remotely, and that does not exclude your queries. Were I to install this query, so there's a difference, I'll get into that difference in a minute, but were I to install this query, I would then be able to click this link right here, and that would just show me the REST endpoint, the exact REST endpoint that I need to call in order to execute this query.
Sorry, Dan?
Yep.
Hi, someone was wondering if you could increase the font size.
Oh, yes, sorry about that. Is this better?
That's good, thanks.
So this is a basic query. I'll show a little bit, this is a bit more advanced query that does some cool stuff that will hopefully give you an idea of some of the cool things that you can do with TigerGraph, people with similarity. I'll just do. So what this post will, or what this query will do, is it will take an input person, and then from that person, it will go across all the posts that they've posted and get all the hashtags from the posts that they've posted. Okay, so we'll get our list of hashtags. That's just what our query was doing before. And then from there, we're going to take every other person that is within our graph, and we're going to traverse over the post that they've liked, and we're going to get a group of hashtags of the posts that they've liked. So for our input person, we'll have a group of hashtags that are related to the posts that they've posted. And then for everyone else in the graph, we'll have a group of hashtags related to the posts that they've liked. And then what we're going to do is run a similarity algorithm to compare those lists to each other and to attempt to find people who are most likely to like posts that our input person has posted based on their hashtags. So I forgot that this one also has a subquery, so I just need to create that as well. So you can call queries from within other queries. You can have subqueries and do all of that. So I'm just going to add in my similarity query that I've pre-written here. And we'll save that. And this you will need to install. So you can run queries in what's called interpreted mode. So that is, as I've been doing it now, where you just write the query, you click the save button, and you're able to automatically run it. There are some limitations as to what functionality your query can have when it's being run in interpreted mode. So the other option is to install your queries. Now, installing your queries will create that endpoint, but it also optimizes your queries and basically just converts them into TigerGraph's internal language, which it will use for actually running queries. So it will convert these down to C++, and that will actually be what's run within your TigerGraph. So it will be much more performant. And when you're running in a real world scenario where you have a deployment, you will want queries to be installed. But if you're just playing around, if you're just writing your queries and you need to be able to test them, then you can run them in interpreted mode. So you don't have to wait the minute or two for your query to install. So we just need to install the similarity query if we want to use it as a subquery. But that, like I said, will just take a minute or two for that to roll through. The similarity query is basically just doing Jacquard similarity. So we're just comparing A and B. We're looking for the overlap versus the total size of those groups. And we're going to return a number between 0 and 1 that will represent how similar they are. So once that's done installing, then we can actually run our other query and we can see some of the cool stuff there. So just let that go. There we go. So now if we hop back over this query, we'll see that it is no longer complaining about our similarity query not existing, and we can go ahead and run it. So I'm going to say I want to find all of the people who are most likely to like person 30's posts. And I only care about the top 10 people who are most likely. I'll go ahead and run that query. And here we can see that, person 72 has a little bit less than 20% of their hashtags in common with the post that person A has made, and so on and so forth. And we could do this with really anyone in our graph, and we can get that similarity. So that just kind of shows how by pulling all of these things together in graph, we're not just able to look at kind of our person and what they post and those hashtags, but now we're able to take that person and compare them to the rest of the people in our graph in this query that can run in milliseconds. This is obviously a very small demo graph, but the performance here is something that scales way beyond a data set small enough for me to include in a demo. So we have graphs that have millions into billions of edges that are still able to run queries like this in a matter of milliseconds to seconds. So it's very cool kind of to see the performance that those installed queries have, and to get an idea of some of the things that you can do by doing these multiple traversals and comparing data across all of your graph. I know I'm running out of time, so I'll just add in one last little thing. When running your queries, it's very handy down here to be able to view your schema, because obviously you need to create these linkages, and memorizing a big complex schema is something we would never ask anyone to do. So it's nice to be able to have that interface here. And then again, like I said, this JSON result shows you an idea of this is exactly what you will get running this query through a REST endpoint. This will be your return. So good to use that and kind of be able to look at that stuff when you're developing things out. Like I said, Graph Studio is great for kind of exploring like this, but obviously the real power of TigerGraph comes from how you connect it to different data sources, to different applications. So feel free to check out, I can include some links. We have some documentation on how you can do all of everything that we've done. So this entire demo that I walked through this Graph Studio interface, I'm going to give you a notebook which will show you how to do all of that in Python code. So yeah, so that's the bulk of it. I know that was kind of a lot that I just threw at you in the last hour or so, but that is your intro to TigerGraph, and hopefully that was easy enough to follow along. And I look forward to seeing what everyone creates with TigerGraph.
Thanks, Dan. That was amazing.
Thank you.
Do you have time for questions, or should we?
Oh yeah, certainly. Happy to answer questions.
So if anyone has any questions, please put in the chat.
Can you use JDBC connection to pull graph data into a graph database? You certainly can. In fact, we have a JDBC driver that you can grab from our TigerGraph Dev Labs. 1 second. So TigerGraph Dev Labs, I'll drop this link in here. I'll also make this a bit bigger so everyone can read it. But this is all of our sort of graph supported or TigerGraph supported repositories that we've released. And I believe somewhere in here, there is a TigerGraph JDBC driver that you can use. Let me find it. And if not, then you can check our community site. So this is developers.tigergraph.com/community. And by going into the ecosystem side, you can see here, we can search for JDBC, and there's our TigerGraph JDBC driver, and we can visit that GitHub page here. So yes, we do have a driver. Main differences or advantages of TigerGraph compared to competitor projects like Neo4j. So one of the biggest advantage, or I guess comparison between TigerGraph and Neo4j is the way that we scale. Neo4j's fabric relies on a central node in order to control other nodes of the graph. So I'm sorry, these aren't nodes as in like graph nodes, but these are nodes as in compute nodes. So both TigerGraph and Neo4j can scale across multiple machines if you need to scale your graph up. TigerGraph though is natively parallel, where I only have to write one query. So for example, these, those queries that I was writing before, I only have to write that once. Whereas with Neo4j, you have to shard your data. You have to pick what data goes into which one of those machines. You have to then write a query for each one of those machines based on what data is in it. It's just not a natively parallel experience. So in terms of being able to load up a huge graph, easily write queries and run everything massively in parallel and get the full performance advantage, there's really no contest between TigerGraph and Neo4j. And then let me throw in some more links here. So we just have a, oh, sorry, I realized I wasn't sharing my screen when I was showing off the JDBC driver. Sorry about that. But here are, yeah, so here's our developers.tigergraph.com site. You can head into the ecosystem to view any of our ecosystem tools. There's the JDBC driver, and you can view it just by selecting View Project. Will take you to the GitHub page for that. Additionally, on this site, here's our our community. There are plenty of ways to contact TigerGraph developers like myself. If you have any questions, if you have anything you're looking to work through, our Discord and our community forums are definitely two of the best places to go for that, where you can just send us a message and we're happy to help out, help you troubleshoot your query, help you design your schema, figure out if TigerGraph is, or Graph is the best for your use case even. So we're always happy to help out however we can there. And then we have plenty of educational content on both YouTube, GitHub, and a few other places like Medium, where we have plenty of blog posts and everything as well. So I'll drop this in here for anyone who would like to participate in our community. And then additionally, let's see, any difference when running between GCP, AWS, and Azure? Nope, no difference, just where your instance lives. And then this deck I will share out with all of you. Here is a link to that as well, just so you can see the idea of the schema and everything that we're building out. And there's a little bit more information here around those use cases, but I'll get into those a bit more in future sessions.
Awesome. Thanks again. I'd like to thank Dan, TigerGraph, and WeCloud Data. The next meetup is on September 2nd, Introduction to Graph and Application, specialized session on supply chains. And thank you everyone for attending today, and see you next time.
Thank you all.